Welcome to Unit 5, Lesson 2, Implicit Differentiation. For this lesson, we are going to have to apply the chain rule. So let's do a quick review. Y equals cosine of x cubed. We want to find the derivative of y. Well, we can apply the chain rule. If u equals x cubed, we know that chain rule says that dy over dx, according to chain rule, is dy over du times du over dx, right? Okay, and we're trying to find dy over dx. So that term we're trying to find, dy over dx. Okay, what is dy over du? If y equals cosine of x cubed and u is x cubed, then that means that y equals cosine of u, not x, u, because u is x cubed. If y is cosine of u, then dy over du, the derivative of cosine is negative sine, is negative sine u. So this term dy over du becomes negative sine u. Finally, du over dx. Well, if u equals x cubed, then du over dx is 3x squared by the power rule. Okay. And to simplify our answer, well, we want to put our answer in terms of x. So negative sine u is really negative sine of x cubed, and then times 3x squared. And that's the answer. Again, we can simplify it as thinking about if y equals cosine x cubed, then y prime is just, well, cosine becomes negative sine, and then we have to also differentiate the inside term, so it's negative sine of x cubed times 3x squared. So that's just chain rule from the last lesson. Here's something that might look a little different. D of dx, so the derivative of y squared with respect to x. Well, first of all, I want to point out that if y is a constant, so for example, if y equals 5, then d over dx has to equal 0, because d over dx of 0 is just, of 25 is just 0. So it depends. But what if y is not a constant with respect to x? So for example, what if y is x plus 2x plus 3? Well, if y equals 2x plus 3, then d over dx, the derivative, well, y squared is going to be 2x plus 3 squared. 2x plus 3 squared. Let me type this up. That's going to equal d over dx of 4x squared plus 12x plus 9, if we expand out. And that's equal to 8x plus 12. So the derivative is going to depend on whether y is a constant. But what if we don't know what y is? How can we differentiate this? What if we don't know y? Well, we can still calculate the derivative for any y. In fact, the derivative for any y looks like this. We apply the chain rule. We're gonna let y squared, I'm gonna call a equals y squared. Okay. Well, if a equals y squared, then d of dx of y squared is really equal to d of dx, the derivative of a, which is dA over dx. So that's what we're looking for. We know from the chain rule that dA over dx has to equal dA over dy times dy over dx. Okay. What is dA over dy? Well, a equals y squared, so dA over dy is 2y by the power rule. Y squared becomes 2y when we take the derivative. Okay. What is dy over dx? Well, we don't know, but we're just going to write it in this form, dy over dx. So I'm just going to make the claim that I'm just going to say, hey, dy over dx is just dy over dx. I write the same thing here. So we have shown that dA over dx is just equal to dy times dy over dx. But remember, dA over dx is the same as d over dx of y squared. In other words, we have already finished our calculation. We have found that the derivative of y squared with respect to x for any y is equal to dy times dy over dx. 2y times dy over dx. That's what we get from the chain rule. Okay. Next, this lesson is called implicit differentiation. What does implicit mean? Well, implicit and explicit are opposite. Explicit means direct. Implicit means indirect, so not direct. So, for example, if you have two people, okay, and the first person tells the second person, "You are ugly." Well, that's very direct. That's explicit. But if the first person tells the second person, if the first person doesn't say you're ugly, but instead, if the first person says, you would look better with nice clothes on. You would look better with nice clothes. Well, the first person is still calling the second person ugly, but the first person never says you are ugly. So it's indirect. That's an implicit statement. So explicit is direct, implicit is not direct. Now let's figure out what that means in calculus with differentiation. Okay, so here's our equation. It's x squared plus y squared equals r squared, where r is a constant. We want to figure out dy over dx. That's our problem. X squared plus y squared equals r squared. We want to find dy over dx. What does x squared plus y squared equals r squared look like? Well, let's go to Desmos. Let's type it in. X squared plus y squared equals r squared, where r is a constant of some sort. If r is 1, oh, that should be like, there you go. Well, if r is 1, then what we have here is a circle with radius 1. If r is 2, then we have a circle with radius 2, and so forth. So this is just the equation of a circle with radius r. Why? Well, given any point on the circle, like right here, any point, we can see that given this point, there's the y, there's the x. We have x and y. And we can make a right triangle. So this is the x that goes to the point. This is y that goes to the point from the x from 0. Well, how long is a hypotenuse? By the Pythagorean theorem, that's just x squared plus y squared. But that's also the radius of the circle. So by the Pythagorean theorem, x squared plus y squared equals r squared. In this problem, we want to find dy over dx. Let's think about what it should look like. Dy over dx. Well, given this triangle, given that r is always 1, if y gets bigger, x must get smaller, right? Because it's a right triangle. If one leg gets bigger, the other leg must get smaller if the hypotenuse is always 1. That means that the slope between y and x is negative. The correlation is negative. So dy over dx must be a negative number. We must get something negative if x and y are positive. Okay. All right, let's actually figure out what dy over dx is. First, we are going to do it directly. That's called explicit differentiation. Direct. All right, to figure out y prime, the derivative directly, we have to find y by itself. Okay, so given x squared plus y squared equals r squared, I want y by itself. So I'm going to subtract both sides by x squared. And I end up with y squared equals r squared minus x squared. Okay. Next, I want to find y by itself, so take the square root of both sides. Remember, square root is just the 1/2 power. So this means exponent. So we know that square root of r squared minus x squared is the same as r squared minus x squared to the 1/2 power. Okay. Next, that means that the derivative dy over dx, or y prime, let's take the derivative. We're going to apply the chain rule. So r squared minus x squared to the 1/2 power. Well, anything to the 1/2 power, the 1/2 comes out in front. And whatever's inside stays there. R squared minus x squared. By the power rule, 1/2 minus 1 is negative 1/2. So that's, in other words, the derivative of this will be 1/2 times r squared minus x squared to the negative 1/2 power. By the chain rule, we also have to take the derivative of the inside term, r squared minus x squared. The derivative of r squared minus x squared is negative 2x. Okay, so there's one more term, times negative 2x. So if y is the square root of r squared minus x squared, then y prime is 1/2 times r squared minus x squared to the negative 1/2 power times negative 2x. Simplify this a little further. The 1/2 and the 2 cancels, but there's a negative out in front. So it's negative of r squared minus x squared to the negative 1/2 power. Okay. Let's write that out. What does that mean? That means negative of r squared minus x squared to negative 1/2 power. Well, if it's negative, that means it's a reciprocal. So I'm going to write 1 over, and the 1/2 power means it's a square root, r squared minus x squared. Okay. And let's not forget the negative 2x. So there's another negative 2x on top. So let me erase the 1 on top and write negative 2x. Okay. So this is, but remember, the square root of r squared minus x squared, this term, square root of r squared minus x squared, that's just y. So I can erase this term and write y. And let's be careful here. Then the 2, this 2, and this 1/2 cancel each other out. I wrote the 2 without writing the 1/2, so they actually cancel. And this is not squared. This is an x right here. Yep, and then I wrote the negative front already. So, in other words, this term simplifies out to negative x over y. And that makes sense. We saw earlier that it has to be negative, and it depends what x and y are. You might say, oh, that looks complicated. Is there an easier way to do it? Explicit differentiation means move everything to the one side, find y by itself, and then take the derivative. But this is a lot easier using implicit differentiation. Let's do it this. So here's an example of implicit differentiation. We have x squared plus y squared equals r squared. Again, okay. Implicit differentiation means we can just take a derivative. We're going to take the derivative of each term. So the derivative of x squared with respect to x. Okay. That's the first term. Plus the derivative of y squared with respect to x. I can split them up because the derivative of a sum is the sum of the derivatives. Like the derivative of x plus 3 with respect to x is just 1, because derivative of x is 1, derivative of 3 is 0. That's equal to the derivative of r squared with respect to x. Okay, what does each of these terms equal? This term, the derivative of r squared, is going to equal 0, because r is a constant. So we know this term is just 0. Not 9, I typed 9, 0. What about this term? The derivative of x squared with respect to x? Well, the derivative of x squared is 2x. Okay. The last term is the trickiest one. The derivative of y squared with respect to x. We have to use chain rule, but we already did that earlier. Earlier in our review of chain rule, we found that the derivative of y squared with respect to x is just 2y, the derivative of the term, times dy over dx. Therefore, this term is just what we found earlier, 2y times dy over dx. Okay. So the derivative of x squared is 0. The derivative of x squared is 2x. The derivative of y squared is 2y times dy over dx. The derivative of r squared equals 0. Okay, what do we do now? Well, we're looking for dy over dx. So we have to find move everything away. So subtract both sides by 2x, and I get 2y times dy over dx equals negative 2x. Divide both sides by 2y, and I get dy over dx by itself is equal to negative 2x divided by 2y. The 2's cancel. I have dy over dx equals negative x over y. We get the same answer, but this time we're using implicit differentiation because we're not putting y by itself. We're differentiating each term individually and then using algebra to find dy over dx. Okay? Let's look at 2 more examples of just implicit differentiation. But the idea is that if you can do it both implicitly and differentiate and explicitly, you should get the same answer. Okay. Example 1. So two initial examples. Example 1. 4x cubed equals 5y squared minus 6. We want to find dy over dx. Let's take the derivative of each term with respect to x. So we have the derivative of 4x cubed with respect to x equals the derivative of 5y squared with respect to x minus the derivative of 6 with respect to x. The derivative of 4x cubed with respect to x, by the power rule, 4x cubed becomes 12x squared. the derivative of 5y squared with respect to x. By the chain rule, 5y squared becomes 10y. And then we have the differential to the inside, which is dy over dx. The derivative of 6 with respect to x, 6 is a constant, that's just 0. So that goes away. So we have 12x squared equals 10y times dy over dx. We want dy over dx by itself. Divide both sides by 10y, and I have 12x squared divided by 10y. Okay. If I want to do the division, that's the same as 1.2 x squared over y. And that's the derivative. Let's look at one more example. This one's a little bit more complicated. Example 2. X cubed y squared equals 3y to the 4th power plus 10x. And we want to find dy over dx. Okay, again, we take the derivative of each term with respect to x. So each term, the d over dx of 3x cubed y squared equals d over dx of 3y to the 4th power plus d over dx of 10x. Okay. So the first term, d over dx of x cubed y squared. Well, you have, oops, sorry, typo. I wrote 2 equal signs, so it should just be a plus. Alright, the derivative of x cubed y squared with respect to x. We have to apply the product rule because we have x cubed times y squared. The product rule says is the first term times the derivative of the second term plus second term times the derivative of the first term. So first term is x cubed. The derivative of second term, the derivative of y squared with respect to x, we saw earlier, is y squared becomes 2y, and we have our dy over dx. Plus our second term times the derivative of the first term with respect to x. The derivative of x cubed with respect to x is 3x squared using the power rule. Okay. Next, the derivative of 3y to the 4th with respect to x. 3y to the 4th becomes 12y to the 3rd power. Power rule. But chain rule times dy over dx. Plus the derivative of 10x with respect to x is just 10. Okay. But now, what are we looking for? We're looking for dy over dx, right? So that means that we want the 2 dy over we want dy over dx by itself. So first, let's put all the dy over dx terms on the left-hand side. So we have x cubed times 2y times dy over dx. And the other term is 12y cubed times dy over dx. That's on the other side. Let's move it to the first side by subtracting both sides by that term. Okay. So the other term is going to be 12y to the 3rd power. Yeah. And then move all the terms without dy over dx to the right-hand side. So it's 10 minus y squared times 3x squared. Okay. Now we can factor out dy over dx on the left. So we have dy over dx. The terms that have not been factored out, we have x cubed times 2y minus 12y cubed. And that's equal to the term that we have on the right, 10 minus y squared times 3x squared. Finally, to find dy over dx by itself, I divide both sides by this term, the term right next to dy over dx, which is x cubed times 2y minus 12y cubed. So divide both sides by this term. And I end up with the top term, 10 minus y squared times 3x squared, divided by the bottom term that we divide on each side, which is x cubed times 2y minus 12y cubed. We have dy over dx by itself. We are finished. So that is implicit differentiation. Okay, that's it.